Hi guys, I'm Engineer HB and welcome to Derive. So in today's video, we're going to start answering sample problems for the Introduction of Machine Design Part 2. And we already did some problem solving way back on our first video, which is the Part 1. And ngayon naman mag-answer ulit tayo ng sample problems. So halika, sundan nyo ako and sagutan natin ito. And don't forget your calculator guys. So let's do this. So we have first question. The shaft whose torque varies from 2,000 to 6,000 inches pounds has 1.5 or 1.5 inches in diameter and has 60,000 psi yield strength. Compute for the shaft mean stress. So sa atin, no, medyo ako never, kung sa normal na usapan, shaft mean stress na is never heard sa atin. Pero don't worry because shaft mean stress is also the same as the shaft average stress. So pag sinabing average, kunyari meron kang 4 and 6 and you are looking for the average number, so just add the 2 value and divide it by 2 and you're going to have the average value, which is a case ni 4 and 6, meron kang amount na 5 as your average number. So the same dito, we need to have a 2 value in order for us to have a average stress. So, since this is a torsional scenario, we all know, wala ako ng yellow ink, we all know that the average stress, no, kunyari, wag muna average. Yan. So, sa torsional stress, we all know that the formula of 16T over phi d cube, and convert natin sa magiging average stress. So in order for us to have an average stress, meron din dapat tayong average torque. Okay? And sabi ko nga kanina, in order for us to have our average stress, we need 2 values. So kailangan meron tayong 2 values ng torque. No? So kunyari meron tayong shaft dito, no? Ang normal na problem ay meron lamang siyang isang value ng torque. Pero in this case, we have a varying torque amount of 2,000 to 6,000. So maaring dito sa dulo, naka-experience lang siya ng 2,000, tapos papunta naman dito sa kanan ay naka-experience na siya ng maximum value of 6,000. So we can say that the average torque is the maximum torque plus the minimum torque value divided by 2. And that was 6,000 plus 2,000 divide 2. So that will become 8,000 divide 2. So it will be 4,000 inches pounds. Okay. And ayan. So direct substitution. Our average stress is 16 times 4,000 pounds inch divided by pi d cube. So our diameter is ito, 1.5 inches. So 1.5 inches. So that will become 1.5 cube. So it will be inches cube. So cancel, isang inches, magkakaroon ka ng inches squared yan. So pounds per inches squared is a PSI. And ayun, so that will be 16 times 4,000 divided by pi times 1.5 cube. So that was 6,036.1 PSI. So meron ba tayong malapit na sagot? So ito, yun, letter A. Meron tayong 6,036 PSI. Okay, so that will be our first question. So proceed tayo sa second question. Determine the deflection of a 4 by 8 inches steel beam if load of P is equal to 1,000 pounds is applied at the center with beam's length of 25 feet. So consider natin guys na meron tayong beam dito. No? So ang pangit ng beam ko, no, hindi diretso. So kunyari yan, diretso na yan. So it is 25 feet. Merong nag-apply daw na P is equal to 1,000 pounds sa gitna. So tinatanong deflection. So ito ganito guys, kapag walang binigay na scenario kung anong support meron ng isang beam, just assume agad or just assume immediately that is a simply supported beam. So pag sinabing simply supported beam, we have 2 supports at both ends, no? Ang hinahanap deflection, syempre, Wala tayong deflection here, wala tayong deflection here. Of course, kapag may nag-apply na load sa gitna, no, kunyari ito yung calculator mo, may nag-apply na force, may na-apply na force sa gitna that will become deflected. So, meron siyang deflection dito. Kunyari, exaggerated na natin. No, burahin ko tong length. So, kunyari, ito yung deflection. No? Okay. Yeah, so that will be the deflection. So, and we all know way back on our strength of materials, no, hindi natin kailangan mag-shear and moment diagram. We all know that the deflection for this kind of simply supported beam with applied force at the center of the beam is PL cube over 48 EI. And P is the force, ito, na in-apply sa gitna. Yung L is length ng beam, which is may binigay na 25 feet. No, lista na natin. And letter E stands for the modulus of elasticity, which is kapag walang given, lalo na kapag English unit ang given, ang problem, so that will become 30 times 10 raised to 6 PSI or pounds per inches squared. And our I is the moment of inertia. So since we have a rectangle, we all know that the moment of inertia of a rectangle is BH cubed over 12. Okay? So before I will substitute all the values, mag-unit analysis muna tayo. So in order for you to have a deflection in inches, kasi inches yung mga nasa choices, isa-isahin natin. Si P, dapat ay pounds. Si L, kung gagawin natin inches lahat, so that will become cubic inches. Si letter E, which is modulus of elasticity, that was pounds per inches squared. At kung gagawin naman natin inches, si I, which is inches si base, si height ay cubic inches, so that will become inches raised to 4. So that was cancel si pounds. Aakyat yung inches squared sa taas, that will become inches raised to 5. Ang bottom mo inches raised to 4, and that will become inches. So, kailangan si P is nasa pounds daw, which is correct. Ito kailangan nasa inches, si length. So, that will be, convert muna natin si 25 feet sa inches, and that will become 25 times 12. So, that was 300 inches. So, dapat daw si modulus of elasticity is naka-pounds per inches squared, which is correct here. Correct sa length. And our I should be inches raised to 4. So we have a 4 by 8 beam. Okay. Inches. So that will become 4 feet times 4 inches times 8 inches raised to 3 divide 12. So that will become 4 times 8 cube divide 12. And that was 170.67 inches raised to 4. And ang dapat kanina rito is naka-inches raised to 4, inches raised to 4 to. So everything is correct. No? So our deflection will be direct sub. So that was 1,000 times 300 cube divided by E, which is 30 times 10 raised to 6, and our I is 170.67. So our deflection will be 1,000 times 300 cube, divide mo round ng 30 times raised to 6, divided by 170.67. Tama ba? So that was PL cube over 48. Meron pa tayong 48 dito pala. Ayan, kasi 48 EI. Divided by 48. So our final answer is 0.109, approximately 0.11 inches. So meron ba tayong 0.11? 1.1 ito. Ayun. So we have this 0.11 for letter A. Okay? So dalawang question na yung nasagutan natin. So we're going to proceed for the third. Sabi, what is the bending moment in feet-pounds at the fixed end of a 10-feet beam with a uniform weight of 100 pounds per feet and a concentrated vertical load at the free end of 1,200 pounds? So sabi, ang sitwasyon daw ay isang beam na merong fixed end. So pwede nating assume that this is a cantilever type beam kasi meron kang fixed end tapos free end to. No? Kasi sabi dito free end and this is a fixed end. So this is your fixed end and this is your free end, no? Suburahin ko lang itong ano. Ayoko ng medyo gusto ko straight na beam. Yeah. Okay. So sabi, what is the bending moment in feet-pounds at the fixed end of a 10-feet beam? So lagay na natin 10-feet beam with a uniform weight of 100 pounds per feet. So meron tayong uniform weight dyan. So that was 100 pounds per feet. So lagyan na natin ng arrow para ma-familiarize ka that this is a uniform weight load. And a concentrated vertical load, no, at the free end. So saan ba yung free end natin? So ito yung free end. So lakayan na natin. So meron din daw diyan, no, na 1,200 pounds. So ang hinanap, bending moment. So since guys this is a fixed end or a cantilever beam, so kahit hindi na tayo mag-shear end moment diagram because pwede na tayo mag-apply ng moment yan. Kasi wala namang other involved na forces, kundi doon lamang, itong dalawa lamang na uniform weight load and concentrated load. At syempre, meron tayong moment doon sa free end. And we can tell that the moment at the free end, no, is the summation of the moments doon sa beam. Kasi ibig sabihin, kina-counter ng moment ng wall, ng fixed end, yung applied load dun sa shock. So we can tell that the moment here is equivalent to the summation of moment on this. So pwede rin naman tayong mag-summation, pero sige, para din nakalito. No? Dito na tayo, summation. O, pwede na natin mag-summation. Kunyari point A to. Let's go from point A. So that will be 1,200 times 10 feet. Kasi 1,200 from point A, that will become 10 feet. Ang hinahanap nating unit kanina dito is feet pounds. So this will become pounds. And this is feet. So it is okay. Plus, hindi lamang tayo may concentrated load, kundi meron rin tayong uniform weight of 100 pounds per feet. So that was 100 pounds per feet. So in order for this na makancel yung feet, kailangan mo ng center niya papunta sa free end. And this, since this is a rectangular, ibig sabihin, ang center ng uniform weight load is nasa gitna ng beam, which is 5 feet from point A. So that will become 5 feet. No. Unahin muna natin pala si 100 pounds per feet. Since this is a rectangle, guys, and this is a uniform weight load, ibig sabihin, nakadistribute yung force per feet dun sa beam, which has meaning of 100 pounds per feet. Ibig sabihin, kada feet meron siyang 100 pounds, pero kailangan muna natin i-convert to 100 pounds per feet on equivalent concentrated load. And since this is a rectangle, this is a area of length times width. So kung ito yung rectangle mo, ito yung width, ito yung length mo, ito yung width mo, we all know that the width is 100 pounds per feet and your length is 10 feet. So area lang yan, W times L. So this will be 100 times 10 feet. So meron ka ng equivalent, no? Equivalent single load or concentrated load. So this will become, cancel yung feet. Cancel yung feet, so may pounds ka na. And syempre, kailangan din kung saan yung kinonvert na concentrated load here papuntang free end, yun yung magiging distance mo dito. Kasi nga moment is force times distance. So that will become 100 times 10 times 5 feet. So this is pounds na natira kanina kasi kinancel na yung feet. And this is feet. So everything is perfect. So The answer will be 1,200 times 10. That was 12,000. Plus 100 times 10, 1,000 times 5. So that will become 5,000. So it will be 12,000 here, and you have the 5,000 here. And 12,005 plus 5,000, that will become 17,000 pounds. Okay. So, meron tayong answer. So, ang answer saan malapit? So, ayun, meron tayong 17,000 sa letter D. Okay, so nakatatlo na tayo, guys. So, pang-apat naman. Steel railroad rails 10 meters long are installed with an initial clearance of 5 mm at 10 degrees temperature. Excuse. Assume coefficient of thermal expansion of steel of 11.7 times 10 to the negative 6 meters per meters degree Celsius, and E is equal to 209 gigapascals. At one temperature will the rail just touch? So, guys, as an engineer, napag-aralan na natin ito sa strength of materials, no? Na kaya naglalagay ng clearance sa mga relays kasi kapag may thermal expansion, dun magkakabit yung relays. Ibig sabihin, there's a change or increase in temperature. Kaya, eto kunyari yung relays mo sa isang gilid at ito yung isang relays mo. So, meron lagi yung clearance, which is a problem given is 5 mm. So, ang hinahanap, at what temperature will the rail just touch? Di ba we all know that the steel is nag-expand pag may change in temperature, lalo na kapag nag-increase. So, anong temperature daw magta-touch itong dalawang relays with a clearance of 5 mm? So, we all know that the clearance, no, is equal to coefficient of thermal expansion times length times change in temperature. So in unit analysis, meron tayong thermal expansion dito of steel, which is 11.7 times 10 to the negative 6 meter per meters degree Celsius. That was, ayan, meter and meter degree Celsius sa kanyang unit. We all know that the length, ano bang length natin dito? So meron tayong length na given which is 10 meters long. So sulat ko na rin si coefficient of thermal expansion. So, pangit ang sulat, ulitin. Negative 6 only. And, okay, since this is a delta T, so it is both Kelvin or degree Celsius, pero no need to convert to Kelvin because it is a difference, so degree Celsius na din. So, meron tayong length na meters and delta T sa degree Celsius, which is delta T is final temperature minus initial temperature, which is TF minus, ang sabi, with an initial clearance of 5 mm at 10 degrees temperature. So this will become 10 degrees Celsius. Okay, syempre, kailangan mas malaki yung makuha nating temperature kasi nga, nag-expand yung steel mo, syempre, mataas yung naging temperature. So this is a degree Celsius. So canceled, 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 canceled. Ang matitira is meters. So mamaya natin i-divide or i-times sa 1,000 para maging 5 mm. Or pwede rin namang si 5 mm ay i-convert na natin sa meters. Kasi nga meters ang natira dito, your clearance should be meters also. So ayan, this is a direct substitution problem. So 5 mm, divide muna natin sa 1,000 mm. Times 1 meter, so that will be 5 divided by 1,000, that was 0.05. Tama ba? 0.005 meters. So this will be a direct substitution. So 0.005 is equal to 11.7 times 10 to the negative 6 times length of 10 meters. And delta T is T minus 10. So TF minus 10. So that will be So the approach here is 0.005. I-divide mo muna ng 11.7 times 10 to the negative 6. At i-divide mo ng 10. At matitira na lang dyan is answer is equal to t minus 10. So pukol mo si minus 10 sa kabila. Answer plus 10. So our final answer is 52.735 degrees Celsius. Ibig sabihin, you need 52 degrees Celsius na temperature in order for your sa yung relays na magtagpo with a given clearance of 5 mm. So meron bang choices na 52? So magkakamukha yung choices. So ayun, meron tayo dito, which is letter C, 52.73. Okay, so ayan. Dito na tayo sa last item. Pero mukhang medyo mahaba to. Pero halika, tirahin natin to. Itong tanong na to. An 8 inches long steel has a cross-section area of 0.25 square inch. After a load of 5,000 pounds has been applied, the length is found to be 8.0065 inches. Find the unit stress. So I will draw first the scenario. Meron daw tayong 8 inches long na steel and has a cross-section area of 0.25 inches squared. Ayan. So hindi diameter ang given, area na. And after a load of 5,000 has been applied, the length is found to be 8.0065. So dito na lang natin drawing. No? Pagkatapos daw ma-i-apply yung 5,000 pounds, the length is found to be 8.0065. Ibig sabihin tumaas. No? So kunyari ito yung naging extension. So kung ito is 8 inches, so this will become 8.0065. Kasi in-applyan ng 5,000 pounds. Sabi, find the unit stress. So since guys, this is a tension, or axial stress, we all know that ST or tensile stress is just simply as force over area. And we all know, ano bang given force? So may in-apply na force of 5,000 pounds. And syempre, perpendicular area. So that was, ano bang given na area? So it is 0.25 inches squared. So pounds per inches squared, ang magiging sagot is PSI. So that was 5,000 divided by 0.25. And there you have it. We have the 20,000 PSI. So kung nagtatanong ka, guys, o nagtatanong kayo guys kung bakit F over A basta agad. Kasi nga, ang bukod tanging force na in-apply is 5,000 pounds at ang napansin natin, yung length is found to be 8.0065, which is tumaas. Ibig sabihin, nag-apply ka ng tension or hinatak mo yung bakal by some massive force para ma-extend siya. So this just a simply force over area. So 5,000 divided 0.25, so that was 20,000 PSI. So meron ba tayo dito? So that was go for letter C. And we have 2 remaining. No? So what is the unit strain induced? Okay. So we all know that the unit strain is just the ratio of the change in length divided by the original length. The purpose of the unit strain, para malaman mo yung amount, para malaman natin kung ilang amount ang nabago per length. So kaya nakalagay dito is change in length over original length. So we all know that the change in length is ito yung nagbagong distansya, no? And that was 8.0065 minus 8. Burahin natin. Ayan. And of course, our original length, bago in-apply yung force, is 8 inches. So that was 8.0065 minus 8 divided 8. So that was 125 times 10 to the negative 4 or 0.008125 inches per inches. So, yun yung unit ng strain, no? So, dapat dimensionless siya kasi parehas lang. Pero, syempre, ang purpose nga is to know what is the amount nung nagbagong length per original length. So, that was inches per inches. So, that will be 0.008125. Meron ba tayo? Meron tayong 0.81 sa D. So, 0.00, ito, sa letter A. Tatlong 0 and 81. So, this is tatlong 0.8125. So, this is also correct. So, this is for the letter C. And ito naman ay for letter A. Ayun. So, last item. What is the modulus of elasticity and PSI? We all know that the stress is also equivalent to modulus of elasticity times strain. Ang derivation nito is that ang sabi, stress daw, wait lang. So ang sabi, ang stress daw, lagi ko na ano to, no? Yan. Sabi, ang stress daw is proportional to a modulus of elasticity or or strain. Kaya we need to introduce, no, a new property which is the strain. Ay, hindi. Ang alam ko, ito is proportional to strain. So that will become S is equal to modulus of elasticity times strain. So since hinanap is modulus of elasticity, that will become E is equal to S divided by strain. So ang S natin kanina is 20,000 and our unit strain way back on our second item is 0.008125. And there you have it. Our answer will be on PSI kasi dito considered na siya as dimensionless and dito is PSI, so that will become PSI. Ay, nawala. Ayan, ayan. So nagmamadaling matapos. 20,000 divided by 0.008125. That was 24,615,384.62 PSI. Or, pwede natin siyang sabihin 24.615 times 10 raised to 6 PSI. So, meron ba siyang malapit? Ayun. So, that was for letter A. 24 and 690. So, medyo malayo, no? Hindi naman sa medyo malayo. Pareho naman siyang 24 million. And siya lang naman 24 million the choices. Kaya nagkaganon, guys, kasi ang choices kasi dito sa B, ay sa second item is 0.0081. While me applied or write 0.008125. So, try natin yung 20,000 divided by 0.0081. Ayun. So, doon lalabas yung 24,691. Okay? Nagkataon kasi, naglagay naman ako ng 25 sa dulo. That will become, kaya bumaba. Pero, luckily, siya lang yung may 24. So, that was letter A. Okay. So, ayun lang guys, no? Medyo mahabang ating napag-usapan and I hope may natutunan tayo at nakapag-practice tayo na kahit paano. So, I hope nakatulong ako sa inyo and ayun, stay tuned lang sa mga videos na i-upload pa natin, no? Sasamahan ko kayo, no? Sa pagre-review sa board exam. Syempre sa machine design and syempre meron din tayong engineering mathematics and meron din tayong power plant. So, ayun lang guys, salamat sa pagsama and see you on our next videos. Let us learn and let us derive. Bye-bye. Hoy, ay taktaw ko ulit. Hindi ko na i-edit, no?